Have you ever wondered how volcanoes, the fiery giants of nature, come into existence? These colossal wonders, as old as the Earth itself, are more than just mountains. They are portals into the inner workings of our planet. Volcanoes are nature's way of venting. They are born from the Earth's fiery mantle, where temperatures reach thousands of degrees. When the Earth's tectonic plates shift, gaps are created. The molten magma, under tremendous pressure, sees an opportunity and seizes it. It forces its way up to the surface, creating a fiery path that culminates in what we know as a volcano. Each volcano is a testament to the unstoppable forces of nature that have shaped our world. They are architects of the Earth's landscape, carving out valleys, raising mountain ranges, and forming islands. Imagine Hawaii, a paradise born out of volcanic activity. But volcanoes are not just creators. They are also destroyers. Their eruptions, while breathtaking, can be deadly. Ash clouds can blot out the sun, fiery lava can engulf landscapes, and volcanic gases can poison the air. Yet, in their destructive wake, they leave behind fertile soil that nurtures new life. It's this duality of creation and destruction that makes volcanoes so fascinating. They are a reminder of the Earth's volatile past and a window into its fiery core. They come in different shapes and sizes, each with its unique characteristics. From the towering stratovolcanoes to the bubbling lava lakes, each volcano has a story to tell. A story of its birth, its life, and its inevitable death. Understanding volcanoes is not just about uncovering the secrets of our planet, it's also about predicting their future activity, mitigating their destructive potential, and harnessing their creative power. So let's start our journey from the beginning, the birth of a volcano. Every volcano starts with a fascinating process called subduction. Now, you might be wondering, what's subduction? Well, imagine the Earth as a giant jigsaw puzzle, with pieces that are constantly moving, albeit very, very slowly. These pieces are tectonic plates, and when they collide, things get interesting. You see, when one tectonic plate encounters another, they don't just politely sidestep each other. No, they engage in a titanic struggle. In most cases, the denser plate will be forced downwards beneath the other plate into the Earth's mantle. This process, my friends, is subduction. But what happens next? As the descending plate plunges deeper into the mantle, it begins to melt due to the intense heat and pressure. This melting creates a semi-liquid, gooey substance that we call magma. Magma is lighter than the solid rock around it, and just like a cork in water, it seeks to rise. As the magma ascends, it carves a pathway through the Earth's crust, creating a conduit, or a pipeline, if you will. This conduit serves as the magma's escape route to the surface. Now, if the magma successfully reaches the Earth's surface, it results in a volcanic eruption. But if the magma gets stuck somewhere along the way, it cools down and solidifies, adding another layer to the growing magma plug or dome. Over time, repeated eruptions and magma accumulation can lead to the formation of a mountain-like structure, which we recognize as a volcano. This formation process can take thousands, even millions of years. The Earth, it seems, is not in any rush. So there it is, the birth of a volcano from subduction to eruption. A process so grand, so powerful, it never ceases to amaze. It's a testament to the dynamic, ever-changing nature of our planet. And to think it all starts with two tectonic plates bumping into each other. As the magma rises, it begins to form what we know as a volcano. Not all volcanoes are alike. In fact, there are several types. Just as the world is full of diverse landscapes, so too are the types of volcanoes that shape them. First, let's talk about shield volcanoes. Named for their broad, shield-like shape, these giants are primarily built by the accumulation of fluid basalt lava. Think of them as the gentle giants of the volcano world. Their eruptions are typically less explosive, instead producing flowing rivers of lava that slowly build up the volcano's wide, sloping sides. The Hawaiian Islands, for example, are primarily made up of shield volcanoes. Next, we have cinder cone volcanoes. These are the smallest type of volcano and are characterized by their steeply sloping sides. Cinder cones are built from particles and blobs of congealed lava ejected from a single vent. As the gas-charged lava is blown violently into the air, it breaks into small fragments that solidify and fall as cinders around the vent to form a circular or oval cone. Pyroclastic in Mexico is a classic example of a cinder cone volcano. Lastly, we have composite or stratovolcanoes. These volcanoes are what most people envision when they think of a volcano. They're composed of layers of lava flows, volcanic ash, and cinders. The alternating layers are what give these volcanoes their name, with strato, meaning layered. These are the most explosive of the volcanoes and can cause catastrophic damage when they erupt. Mount St. Helens in the United States and Mount Vesuvius in Italy are both stratovolcanoes. From the gentle, flowing eruptions of shield volcanoes to the explosive power of stratovolcanoes, each type of volcano is unique. They differ in size, shape, and eruptive style. And while they can be destructive, they also play a crucial role in shaping our planet's diverse landscapes. Each type of volcano has its own unique characteristics, making them as diverse as the landscapes they shape. As we continue our journey into the world of volcanoes, remember that these natural wonders are as varied and complex as the Earth itself. A volcano is much more than just a mountain spewing lava. It has a complex structure. Now, let's delve into the anatomy of a volcano. Picture a volcano not as a simple cone, but as a substantial system with interconnected components that work together to produce the spectacular eruptions we see. Let's start with the magma chamber, the birthplace of an eruption. This is a large, cavernous space deep within the Earth where magma accumulates. Magma, a molten mix of rock, crystals, and dissolved gases, is lighter than the surrounding rock, and so it rises, creating pressure within the chamber. Next up is the vent. This is the highway that magma uses to travel from the magma chamber to the surface. The vent is a conduit or a series of conduits that extend from the magma chamber through the crust and out of the volcano. At the summit of the vent is the crater, the opening from which the magma escapes. Craters are typically bowl-shaped and form as a result of the explosive force of an eruption. Some volcanoes may have many craters, while others may have just one main crater, also known as a caldera. Now, let's talk about lava flow. Once the magma reaches the surface through the crater, it is then called lava. Lava flows are streams of molten rock that pour or ooze from an erupting vent. The behavior of lava flows can vary greatly, from slow-moving rivers of molten rock to explosive fountains of fiery debris. All these parts work in harmony during an eruption. The pressure in the magma chamber builds up until it forces the magma up through the vent. Once the magma reaches the surface and erupts from the crater, it then flows down the sides of the volcano as lava. Understanding the anatomy of a volcano gives us insight into what happens when a volcano erupts. It's a fascinating glimpse into the dynamic processes happening beneath our feet, shaping the surface of our planet in dramatic and often unpredictable ways. An eruption is a volcano's most dramatic event. It's a process that unfolds in three main stages: the pre-eruption, the eruption, and the aftermath. Pre-eruption signs often begin with seismic activity. The magma chamber fills up, causing the ground to swell and become unstable. Even the smallest tremors can signal an impending eruption. Then, as the magma rises, gases trapped within it start to expand, creating pressure. You might also see changes in the volcano's gas emissions. These gases, rich in sulfur dioxide, can paint the sky with vibrant sunsets, a beautiful but eerie warning sign. The eruption itself is the second stage. The pressure within the volcano becomes too great, and the magma is forced out through the vent. This is what we typically picture when we think of a volcanic eruption, a spectacular display of molten rock and ash spewed into the air. But eruptions aren't one size fits all. They can range from gentle lava flows that inch their way down the volcano's slopes to explosive events that hurl ash and rocks miles into the sky. Picture the difference between a soda can gently fizzing over versus one that's been shaken and suddenly opened. That's the range of a volcano's power. Lastly, we have the aftermath. Once the eruption ends, the landscape around the volcano is transformed. Ash and lava flows cover the ground, creating new layers of rock. These materials are incredibly fertile, and with time, life will return and flourish in these areas. But eruptions can also have more devastating effects, from destroying entire towns to impacting global climate. Volcanic eruptions are a testament to the immense power of nature. They're a reminder of our planet's dynamism and the constant changes happening beneath our feet. Volcanic eruptions are incredibly powerful events that can have far-reaching effects. Whether it's shaping landscapes, fertilizing soils, or influencing climates, their impact is profound and enduring. The impact of a volcano extends far beyond its immediate vicinity. These fiery behemoths are not just local phenomena, they are global game-changers. Let's start with climate. Volcanoes have a paradoxical relationship with the climate. On the one hand, they release large amounts of carbon dioxide into the atmosphere, contributing to global warming. On the other hand, they emit sulfur dioxide, which forms aerosols in the stratosphere. These aerosols reflect sunlight back into space, causing a temporary cooling effect. Remember the year without a summer in the early 19th century? That was due to a massive volcanic eruption in Indonesia. Moving on to landscapes, volcanoes are master sculptors. They have the power to reshape the very earth beneath our feet. Their eruptions can create new islands like Surtsey in Iceland, or reshape existing ones like Mount St. Helens in Washington. Over time, volcanic soil, enriched by the breakdown of rocks and minerals, becomes incredibly fertile, supporting lush ecosystems and human agriculture. Speaking of humans, our relationship with volcanoes is complex. They have been both a boon and a bane to societies throughout history. Their eruptions can cause widespread devastation, claiming lives and property. Yet, they also provide resources like geothermal energy and precious minerals. Cities like Naples in Italy and Reykjavik in Iceland thrive on these benefits. But the impact of volcanoes isn't limited to the physical world. They've also left their mark on culture and mythology. From the fire god Hephaestus of ancient Greece to the Hawaiian goddess Pele, volcanoes have inspired awe and reverence, fear and respect. Volcanoes, then, are much more than natural disasters. They are creators and destroyers, life-givers and life-takers. They shape not just our landscapes, but also our climate, our societies, and our stories. They remind us of the Earth's raw power and our place within the grand scheme of things. Volcanoes, while destructive, play a crucial role in shaping our world. Are volcanoes our foes, or could they actually be our friends? It's a question that might seem paradoxical at first, considering the destructive nature often associated with these fiery mountains. Yet volcanoes are not just agents of chaos and destruction. They also have a more nurturing side, a side that allows life to flourish. Let's delve into the dual character of volcanoes. On one hand, we know them as formidable forces, capable of causing widespread devastation. Their eruptions can obliterate entire landscapes, spewing ash and molten lava that can wipe out ecosystems and human settlements alike. These eruptions are not just physically destructive. They can also have profound impacts on climate, potentially leading to periods of global cooling. Yet on the other hand, volcanoes are also architects of creation. They play a crucial role in shaping the Earth's surface, forming new landmasses and islands. Think of the enchanting Hawaiian archipelago, a breathtaking paradise sculpted by the relentless work of volcanoes over millions of years. But the constructive power of volcanoes extends beyond mere land formation. Volcanic soil, enriched by minerals from deep within the Earth, is incredibly fertile. This soil is a boon for agriculture, supporting lush vegetation and bountiful crop yields. Some of the world's most renowned wine regions owe their existence to the rich volcanic soils that nurture their vineyards. Moreover, the heat generated by volcanoes is not just a source of destruction, but can also be harnessed for power. Geothermal energy, derived from the natural heat of the Earth's crust, is a renewable and sustainable source of power. Countries like Iceland and New Zealand are tapping into this potential, using geothermal plants to generate electricity and heat homes. So when we ask if volcanoes are foes or friends, the answer is not black and white. They are both. They embody the paradox of nature, the dual forces of destruction and creation. They remind us of the Earth's raw power, its capacity to both give and take away. So while volcanoes can be destructive, they also provide us with many benefits. What does the future hold for these fiery giants? As we look forward, the quest to understand volcanoes becomes more crucial than ever. Scientists worldwide are relentlessly delving into the mysteries of these natural powerhouses, with the aim to predict their eruptions and mitigate their effects. Picture this: the implementation of advanced technologies, such as satellite imagery and seismic monitoring, potentially giving us a heads-up before a major eruption. Envision a world where we could evacuate cities, save lives, and avoid the devastating aftermath of these eruptions. Moreover, volcanoes hold the key to many of Earth's secrets. Their eruptions provide valuable insights into the planet's interior workings and the geological history that shaped our world. By studying them, we deepen our understanding of Earth's past and hopefully its future. So, as our knowledge grows, so does our respect for these towering titans. Our journey with volcanoes is far from over as we continue to learn more about these fascinating natural wonders.